Morning to all. Myself, Arun Egemia from Aerospace Engineering Department. Today I'm going to take one topic from Fundamentals of Aerospace Engineering for us first year students. If the topic name is Development of Aerodynamics. So in the development of aerodynamics, in the topic I'm going to take the four DD stages. First one is empathy. So in that empathy part, the spark of the scientific curiosity. So in that cases, the first person, the spark, it will be uh, taken from the Da Vinci dreams. So in that Da Vinci, they are drawing the like that manner in the year of 1903. So the later the based on the Da Vinci, the Wright brothers are developed by the first flight in the year of 1903. So the many centuries are passed away. So now the fully developed aircrafts and automated UAVs are developed nowadays. Uh, Next one is in the defense stages. The Daniel Bernoulli and his principal, they have told they have implemented the fluid flow and fluid mechanics for these cases. So what are all the laws and what are all the pressure velocity relationship? These can be utilized and developed for the further development of the aircraft. And in that defining part, again they have implement the frontal and boundary layer theory. So in that boundary layer theory, what are all the boundary we are facing during this flying condition, and what are all the drag forces and what are all the wing it will be flying during these cases, and what are all the types of drags found during the flying conditions, and these are all the things it can be developed by the frontal in the year of 1904. And next one is ideate part. So here we will find out the two different type of flow. So first one is a laminar flow and turbulent flow. So in that laminar flow, the smooth and orderly air movement it will be found, like the flow it can be in streamlined manner. And next one is the turbulent flow. So in the turbulent flow, the irregular air flows we will found in that cases. So flow separation. So in that flow separations, here the laminar flow it can be transformed to turbulent flow. So here the flow it can be separated some area like a laminar flow, in some area it is called a turbulent flow. The laminar and turbulent flow it can be taken from the based on the Reynolds number. So definition of Reynolds number is inertial force by viscous force. And by prototyping, the first the Wright brothers they have developed the homemade wind tunnel for testing the aircraft. So in that by testing the aircraft, so how much amount of the laminar and turbulent flow it will be flow during this testing cases. In that testing, the next the Richard bit of area rule they have find out the drags formed during the flying conditions. So in that rule they have drastically reduced the transonic drag. So in that transonic drag it can be while the formation of transonic drag it can be reduce the lift. So if the lift is reduced, means the aircraft it will be fly in that low range area. And they have introduced the supercritical wing. So in that supercritical wing it can be fitted in the flatter top and thicker leading edge. So by implement the supercritical ring, it can be improve the lift to drag ratio up to 15%. And by Robert T. Jones and sweatback wing concept, by using the sweatback wing concept. It can be reduce the drag during the flying conditions. So here the in that wing, it will be improve the lift for these cases. And next one is our Theodore and aerodynamic foundation. So in that aerodynamic foundation, they have developed the theory for the supersonic flow, turbulent waves, and shock waves. So in that shock wave, it is a sudden disturbance during the flying conditions. So here he has developed the mathematical derivations for the high-speed airflow. So by concluding the aerodynamics, the many inventors and many scientists are developed and many concepts for the aircraft. So in that Bernoulli's principle to develop the CFD simulations, it can be useful to design the aircraft and what all the flows occur during this air flying the aircraft. So thank you. So we will catch you on next topic on next video.